Hi, my name is Stacy Williams, and I'm a Network Solutions Architect in the Advanced Technology Solutions Group here at CenturyLink. In the next several minutes, I'd like to provide an introduction to the important topic of Network Functions Virtualization, or NFV. Once we've established a baseline on what NFV is and what it can do, I would then like to cover how it relates to our messaging around Platform CenturyLink. I'd like to thank you in advance for your time and attention to this important concept. Today I'd like to cover three areas that I think will help you come away with a better understanding of NFV. First, I'd like to define what NFV is and provide the main driver cited by service providers for adopting this technology. Second, I'd like to get into the specific architecture of NFV as it relates to the ETSI model and go over other important areas such as orchestration and SDN. Lastly, I'd like to bring together what we've learned to see how NFV impacts Platform CenturyLink and look at how we plan on implementing this important technology. Many service providers today go beyond providing basic network connectivity for their enterprise customers. They also offer additional services and network functions such as domain name service, firewalls, IP routing, and others. Traditionally, these network functions were deployed using proprietary hardware at the customer premises. While this approach provides additional revenue, deploying multiple proprietary devices is costly and makes upgrades difficult. Every time a new network function is added to a service, a truck roll may be required to install the necessary hardware. This is the environment almost all service providers today find themselves. Service providers began exploring ways to reduce cost and accelerate deployments through network functions virtualization. Network Functions Virtualization, or NFV, decouples network functions like a firewall and encryption from dedicated hardware and moves this function into virtual servers. Instead of installing expensive proprietary hardware, service providers can purchase inexpensive switches, storage, and servers to run virtual machines that perform network functions. This collapses multiple network functions into a single physical server, thus reducing costs and minimizing truck rolls. If a customer wants to add a new network function, the service provider can simply spin up a new virtual instance of this function on the common hardware platform. NFV refers to the strategy of virtualizing network functions, moving from separate proprietary pieces of hardware to software running on virtual servers using standard hardware. Virtual CPE commonly refers to any network function that runs on a virtual machine. Okay, let's talk a bit about NFV architecture. NFV originated around December of 2012 when service providers came together under the European Telecommunications Standards Institute, or ETSI, and formed an industry specification group for NFV. The group works on defining requirements and the architecture for NFV. The group created a framework to illustrate the various components of network function virtualization and orchestration. It's important to note that the specifications group is not a standards body for NFV, and its role is not to introduce new standards for the technology, instead to leverage networking and communication standards that already exist that fit well with the NFV methodology. The ETSI NFV architecture has three main components: Virtual Network Functions, or VNF, Network Function Virtualization Infrastructure, or NFVI, and management and orchestration. The NFVI represents the physical hardware that provides the virtual resources needed for NFV. This includes compute, storage, and networking, as well as the software layer known as the hypervisor, which virtualizes and manages the underlying hardware resources. OpenStack and VMware are good examples of the virtualization layer. The VNF is the software implementation of a network function like routing or firewall running using one or more virtual machines. The VNF also includes the element management system that manages the individual network functions. A third major piece is management and orchestration. This includes the orchestration and lifecycle management of the physical and virtual resources that support NFV. An orchestrator understands all the resources needed to create and manage a virtualized network function. The orchestrator communicates with the virtualized infrastructure managers and the virtual network function managers to reserve, allocate, and manage the physical and virtual resources needed to deploy a given network function. The ETSI architecture includes interaction with OSS and BSS systems, which allow NFV, to be integrated into an existing network management platform. At the heart of NFV orchestration is the metadata that describes each service, each virtual network function, and the infrastructure below it. These service templates provide the recipe on how the orchestrator builds any given network function. Another important topic I wanted to briefly touch upon is software-defined networking, or SDN, and how it relates to NFV. Many people believe the terms SDN and NFV are interchangeable, but this is not exactly correct. SDN has its own organization called the Open Network Foundation, or ONF. The ONF is an organization dedicated to the promotion and adoption of SDN by service providers and enterprise customers alike. The ONF defines SDN as an emerging network architecture where network control is decoupled from forwarding and is directly programmable. What this is really saying is control is moving away from the proprietary network device layer into accessible computing devices such as virtual machines, which enables the underlying infrastructure and network to be viewed as a single programmable virtual entity. So in reality, SDN and NFV are actually different but complementary to each other in the way that they address different elements of a software-driven solution. SDN focuses on network management and control, but relying on key aspects of NFV such as virtual network elements, such as switches, routers, and firewalls. Without programmable virtualized network functions, SDN could still exist, but service providers would still have to deal with many of the same challenges they face today with a physical box-driven network. The diagram on the slide shows some of the shared functionality between SDN and NFV. Lastly, I wanted to cover Platform CenturyLink and how this relates to the topics of NFV and SDN we spent the last few minutes reviewing. At its basic level, Platform CenturyLink is the commercial name that we've given to our physical implementation of NFV and SDN technologies. As the diagram illustrates, we see Platform CenturyLink divided into three major areas: data center, network services, and customer premises. All three layers will work together to form a single provisioning and management platform for access to the next generation of products and services, many of which will be delivered on a virtual network service platform. Platform CenturyLink is not a product portfolio in itself. Instead, it's an automated, self-service, programmable architecture that will change the way we connect with our customers. Platform CenturyLink is a big topic that deserves its own discussion. Look for another video from the ATS organization on how we are building this platform and how to position this with your customers. Thank you.